Data key products are portable memory devices primarily used in applications where secure, simple, and compact data storage and transfer are required. They allow for non-volatile data storage and are particularly suitable for user identification, software license key transfer, sensitive data storage, and more. They are simple, robust, and reliable storage solutions where small size matters. First, let's get familiar with the Microchip Starter Kit DM320109, which features the SAMD21J18A microcontroller. We will simply see how to make the onboard LED blink using an appropriate programming language. Using Microchip Studio, let's now create a new project and choose the GCC C++ executable project type. Save the project in a designated work folder. From the long list of MCUs, select the SAMD21J18A microcontroller and press OK. The software will create the working folder containing your project. The editor is now ready to accept your C++ code. Now write the simple code provided here. It implements the blinking of the onboard LED. The blinking frequency can be modified by changing the denominator in this ratio. Now access the Tools menu and then Device Programming. Select the correct hardware settings and press the Apply button. Remember to compile the firmware first by pressing the F7 key to generate the hex file. Now access the Memories section, load your generated hex file, and program the device by pressing the Program button. If everything was done correctly, the MCU is programmed immediately and the onboard LED starts blinking according to the firmware's specifications and the user-defined frequency. This introduction was essential to establish the connection with the components needed for recognizing a token device. The parts used are the crypto authentication SOIC X-Pro Starter Kit, part number DM320109, a development board designed to help developers implement advanced hardware security solutions in IoT, embedded, and authentications applications, key cryptographic protection, and prevention of identity theft and device tampering. It is equipped with the low-power ATSEM-D21 microcontroller, the data key crypto authentication extension board SR422-ton PCB, some IAX 10.5 kilobit crypto authentication memory token black, data key part number 611-0235-000A, with Microchip IC80ECC608M. The following example demonstrates token recognition using cryptographic codes. The prototype's operation allows monitoring through the onboard LED of the development board. In particular, if the token is not inserted, the LED remains on. If the token is authorized, it blinks quickly. If unauthorized, it blinks slowly. The code is written in C using Microchip Studio. It is fairly complex and makes many calls to various libraries. This code fragment is the program's header and includes the Atmel software framework, cryptographic management, circular buffer handling, and serial communication, along with the various definitions used in the program. This code defines a list of authorized serial numbers for the tokens. It defines a byte array, and each row of the array represents a unique serial number of an authorized token, consisting of 9 bytes in hexadecimal. This function checks whether a received serial number matches one of the authorized ones by comparing it with the predefined list. The main function contains the program's execution part. After the usual initializations, the actual security checks follow. Finally, an infinite loop checks whether the token has been inserted, and if so, whether it is authorized. If authorized, the LED blinking procedure is started. This code is used to read the serial number of a security token and verify if it is authorized. Depending on the result, it blinks an LED differently. Fast if authorized, slow if unauthorized. It is useful for securely recognizing enabled devices or hardware keys. The test setup requires the starter kit, the data key crypto authentication extension board, a power bank for power supply, 2 unauthorized tokens, and 1 authorized token. Insert the authorized token and observe the LED blinking quickly. Removing the token makes the LED remain steady. Inserting an unauthorized token causes the LED to blink slowly. Without a token, the LED stays on steadily. Inserting another unauthorized token causes the LED to blink slowly. With the authorized token, the LED blinks quickly. Removing the token makes the LED steady. By sending appropriate messages via the serial port, it is possible to know whether a valid or invalid token is inserted, and most importantly, to read its serial code, to be able to program the authorizations. Thanks for watching. For more information and links to these solutions, please check the description below. Stay connected with ESD Lab and don't forget to subscribe to our channel on YouTube.